I say using the addition method. And why would I say that? Well, these two, I have to rewrite this system. And the equivalent system is 3x squared minus 2y squared. Kick the constant to the other side. And 2x squared minus y squared equals, kick the constant to the other side. Again, what these things are, they're two hyperbolas. Ugly looking things. And they both cut the x-axis, so that says I'm dealing with, here's one of them. And the other one is going to come in, and it might look something like this. There's a potential of 4 answers. But they're both going the same direction, so at that point. So if I look at this thing, I'd say, okay, what do I notice? Well, my variables are really x squared. I can solve for here. I would solve for y squared and put y squared back in for y squared here. That would make life nice. So I could say easily that 2x squared plus 2 equals y squared. And then I could replace this y squared with 2x squared plus 2. So that would be nice. I would be using substitution. You place a y squared with a y squared. Or I could notice that these are both x squareds, these are both y squareds. I can use the addition method. So in other words, what I can do is, here's equation 1, here's equation 2. Using the notation we did for matrices, I can take negative 2, multiply it times equation 2, and add it to equation 1. Then I'd have a negative 2y squared and a positive 2y squared, and then when I add, I would end up with the y squareds dropping out. So the addition method will work on this guy. So I'm going to take equation 1, which is 3x squared plus 2y squared equals negative 5. And then I'm going to take negative 2 times equation 2. Negative 2 times equation 2 would give me 4, negative 4x squared plus 2y squared equals positive 4, and I need to cross-check this because I was hesitant. So negative 2 times positive 2 is negative 2, negative 4y squared. Negative 2 times negative 1 is positive 2, and negative 2 times negative 2 is positive 4, so I'm okay. And now you add, y squared drops out. You get that minus 4x squared equals minus 1. Or that x squared equals minus 1 over minus 4. Or that x squared equals positive 1/4.
All right, I got 3x squared with the 4x squared.
Is it just minus x squared now?
Ooh. Well, that was unpleasant. Yeah, it's just minus x squared. I like that better. Phew. I like that one better. Because now we're going to have x squared equals 1, or x equals plus or minus the square root of 1, which is plus or minus 1. Yeah, that was easy enough to finish. I was worried about that 4 from the time I started multiplying by negative 2, by that 4x squared. And now I know that I've got 2 equations. Doesn't matter which one I use. Is that 3x squared plus 2y squared equals negative 5. So if x equals, oh, no, this is also minus 2. y squared, yeah, because otherwise it wouldn't be a hyperbola. And if x equals 1, I have 3 times 1 squared minus 2y squared equals minus 5. 3 minus 2y squared equals minus 5. Oh, this is unpleasant.
You pushed them.
No. And it's going to be just plain belligerent. Minus 2y squared equals, oh, that's not too bad, minus 8. Y squared equals plus 4. Y is plus or minus 2. So I have an answer of 1 plus or minus 2. And if you think about it, I got a twofer, because if I put in x equal negative 1, I'm squaring. So this would be 3 times negative 1 squared minus 2y squared equals minus 5, which is 3 times positive 1, 3, minus 2y squared equals minus 5, minus 2y squared equals minus 8, y squared equals 4, y equals plus or minus 2, which is what it should be the case. Because you're squaring a negative 1, so you end up with the same equation as you had for the other guy. The only difference is the x value is negative 1, the y value is plus or minus 2. So you got 4 places these guys are intersecting. These would be really unpleasant to graph. It would. Extremely unpleasant to graph.